Right. Oh, thank you very much for staying with us, guys. Welcome back to the show. You're still watching Tenfold Live. Thanks for staying with us up to so far. Thank you very much to Liberty for sponsoring our show as well. Remember, you can keep sending us your questions if you want us to assist you with your math. We are doing analytical geometry this week. We are still also going to be there tomorrow with more content between 5 o'clock until 6 p.m. Do stay tuned and keep your questions coming. You stand a chance to win awesome prizes by doing just that. We are continuing with our last question. This question comes from Chilizi. Let's check it out.
Hello, I'm Chidi Zimbeti from Limpopo Mambuka Secondary School. Please help me. It's about analytical geometry.
Right. Thanks for that question. It's a nice question indeed. Let's dive right into it and see how we can help you to make sense of the concept that you're looking at here. Analytical geometry, very basic, simple and not complicated. All right, it says to us here in the diagram R, there's a point R here that is apparently on the diagram. Let's look at it. Yes, there it is. Point R there, and A are X and Y intercepts respectively of the straight line AR. The equation of the line is y equals to minus half x plus 4. Now with that equation, I can immediately know that I'll be able to find the coordinates of A and the coordinates of R if anybody asks me to find them. Minus half x plus 4, I can find the coordinates of A as well as the coordinates of R if anybody asks me to do that by doing the y and the x-intercept. Another straight line cuts the y-axis at point P, which is 0 and 2, and passes through the point M, where M's coordinates are k is 0, and point N, which is 3 is to 4. Right. Then there's alpha here, the angle alpha and the angle beta, which are angles of inclination of the line MN as well as the line AR respectively. Fine, very simple stuff and very nice information indeed from the love letter. Let's continue and see what the first question is asking us to do. Well, they say to us here, given that M, P, and N are collinear, there's that word again, collinear. If you see the word collinear, you must know that they lie on the same line. They lie on the same straight line, right? We want you to work out the coordinates of K. Now, I'm not going to use the same format that we used in the first example because I want you guys to keep learning even more things or new ways of doing this. I will find the equation of that line first and use it to work out the value of K. Let's continue and see how we can do that. So I want to find the equation of the line that passes through M, P, and K. For us to do that, we need a gradient. The gradient is y2 minus y1 all over x2 minus x1. What is y2? I'll take that one. It's 4 minus y1, which is 2 all over 3 minus 0 there. 3 minus 0. The answer that I'm getting here, 4 minus 2, is basically 2. So I'm actually getting 2 over 3 as the gradient. Now, to conclude this, remember the following, guys. If you have y is mx plus c, you must know from your functions that c represents the y-intercept of the line. It's where the graph passes on the y-axis. And we were told that this graph passes at point P where the y value is 2. So I don't even need to worry or waste my time. I'm just simply going to go straight to it and say y equals to 2 over 3x plus 2, because the c value is the y-intercept of the graph, and it is actually 2, which is given to us on the coordinates of P there. So this is the equation. This is the equation of the straight line MPN. That's the one that you're looking at. But we haven't answered the question. Remember, the question is asking us to work out the value of K. Now, like I said, if you've got the equation of a straight line, just take these coordinates. This is your x coordinate and that's your y coordinate, and substitute them in the equation that you're dealing with here. So I'm going to do it here. Since we know that y equals 2 over 3, right, x plus 2. My x value is k, my y value is 0. So I'm going to put 0 equals to 2 over 3 times x is k plus 2. Just sub them in the graph and then simplify this. I don't like this 3 that you see there, the denominator. To undo division, I'm simply going to multiply everyone by 3. 3 times 0 is 0. 2 over 3 times 3 will give me 2k. And then 3 times 2 will simply give me 6. If I simplify further there, I'm actually going to get negative 2k equals 6. Divide both sides by negative 2. Your k comes out as exactly negative 3. Very simple question indeed. I just used the equation of a straight line to figure it out. Quite nice and simple. Always keep that in mind. When you've got the equation of a line, you can take the coordinates and sub them in that equation. You'll be able to figure out what is the correct value of whatever the unknown coordinate you could be dealing with. Let's move on to the next part here. And don't forget these 2 over 3x plus 2. We might need it again in future to simplify or work out the other questions. So now they want us to work out the value of theta. They say to us, determine the size of theta, the obtuse angle between the two straight lines. All right, now if you want me to work out an angle, I'm gonna shift and try to use my knowledge of Euclidean geometry. First of all, I'm gonna try and work out alpha, and then I'm going to try and work out beta. When I've got those two, they should help me to work out the value of theta. Without them, there is nothing I'm going to do. So how does this actually feature in analytical geometry? Very simple. Angle of inclination. The angle of inclination is tan of that angle equals to the gradient that you're dealing with. If I have gradients, I'll be able to get alpha and beta, which I can then use to work out the value of the theta that you see at the top there. Let's have fun. Right. So this line had an equation y equals to 2 over 3x plus 2. This line had the equation y equals to something. What is something? Let's go and check it. It was minus half x, if I remember very well. Minus half x plus 4, if I'm not mistaken. Let's go check it out quickly. Right, it was this one. Yes, minus half x plus 4. That is basically what you're dealing with there. Minus half x plus 4. Right, so I've got the gradient. The only thing I need is the gradient here to work out the value of beta. So I'm simply going to say, let's work out beta and theta. For theta, right, for alpha, before we get to theta, tan of alpha is the gradient of that straight line, which we know is the gradient of the straight line MP, which is basically 2 over 3. That's what tan of alpha is. Right, simplify that further. Then alpha is going to be arctan, that's 2 over 3. Right, and then we're going to need a calculator to work that out. For beta, let's see what will happen for beta. For beta, I need this gradient. So tan of beta is the gradient that we're looking at, which is minus a half. Therefore, beta is just simply arctan minus a half. But because it's negative, I'm going to need to add 180 degrees because we are actually going to get not the angle that is usual. You're not getting this one that you're getting normally. You'll be getting the negative direction. So you must add 180 since angles on a straight line add up to 180 degrees. Right. So let's see what will happen with this question. Very simple. I'm going to now go and get my calculator so that I can be able to work out the value of whatever we need to do here. So shift tan of 2 over 3. Shift tan 2 over 3. What do you get when you do this? Well, you get 33.69. So 33.69. Right, let's go and get the value of beta now. We just found our alpha. We now need to get the value of beta using our calculator again. Shift tan of negative half, that's negative 1 over 2, right, close bracket, plus 180 degrees. If you work this out, you're going to get 153 degrees, comma something, not 153 degrees. I'm going to fix it now, comma 43, yes, comma 43, 153, comma 43 degrees. Very nice indeed, comma 43. So once I have these two, I can then use them to try and figure out the value of theta there. Let's see what will happen if I try to figure out the value of theta. I'm just simply going to say the exterior angle, according to this, allow me to put me in this box. Beta, which is the exterior angle, equals to the sum of interior opposite angles. It's alpha plus theta. So big inclination minus small inclination will give me theta, which means 153.43 degrees minus 33.69 degrees will give me the correct answer that I'm actually looking for. Let's see there. 153.43 minus 33.69. So I'm just going to say minus 33.69. What do you get? 119.74. So 119.74 degrees. That is the value of theta there. A very nice question indeed. Thank you very much for sending us that question. It does allow you to apply your knowledge of geometry as well as analytical geometry in the very same question. So please keep those questions coming in. We are still continuing with analytical geometry. Tomorrow we will be here again to have even more fun with you. I hope you guys enjoyed what we were doing today, but above all, I hope you learned a lot. A big shout out to Liberty for sponsoring our show. Thank you very much for being part of it as well. We've got much love for you guys. We can't wait to see you again tomorrow, 5 to 6. Till then, bye-bye.